chimneys is what I'm calling it today. So that's two chimneys of different construction, and we dropped those in a similar fashion, but it required a different methodology due to their location and construction. The principal, well, the contractor was the demolition contractor Sam Evans and Sons, and the client was British Steel. Specialist Explosive Services were the explosives contractor for the chimney that was blown down using explosives, and we were the demolition engineers providing the design for them both. So we'll start off with the first example, which is the pull down or push down, in this case, of a steel stack. The structure was approximately 5 meters in diameter and 56 meters tall. It had an outer shell and an internal liner, and had a significant section change at about 5.5 meters above the base, which you can see there in that photo. The section change and the intake pipe, which is coming in from the right hand side, that had quite an impact on what we could do, because this meant that we had no restrictions on the pre-weakening. Therefore, if we made the section and had the pre-weakening higher up, that means we could effectively choose where we wanted the to fell the chimney. We had quite a significant site constraint, which was the ammonia tank, and that's one of those tanks you can see there on the photo as well. That was the principal risk, so we wanted to make sure that we were felling the chimney away from that risk. So our design was based on the justification of the pre-weakening and ensuring that there was enough structure to resist any destabilizing forces, which were principally wind loadings. And then what we do is we break the sequence down bit by bit and check each part of the structure by calculating the section properties of each section at each stage, and a little snippet is shown there. And this essentially ensures that the chimney doesn't come down prematurely. And the trick is to remove enough of the sections so that it can be pushed over, but not too much so it blows down in a gust of wind. The structure in this case was pushed down using a grab attachment on the end of the excavator, and this meant that the grab attachment could kind of saddle itself on the profile of that circular chimney shaft, and make sure that we could put the suitable force on there, which was pre-calculated during the design, and then induce the collapse. And here's how it went on one Sunday morning. And that meant that all that structure could be processed and from safely from the ground. That's the intent. And so now onto the other chimney, which was a concrete and as much taller than the steel stack. This chimney was 78 meters tall and nearly 1,000 ton in self-weight. It had a concrete outer ring and then a brick internal liner. There was a large hole on one side of the chimney where the flue came in, and this hole was so large that we couldn't avoid it at all. So we had to work with that opening, incorporating it into our pre-weakening sequence. And fortunately, we were able to make it work so that the chimney dropped in the safe zone and away from the live conveyor systems, which were to the west and south of this chimney. And then this chimney was, as opposed to being induced by being pushed over or pulled over, which we saw in the previous example, this one was induced by explosives. So there was a strict preparation sequence involving test blasts, pre-weakening, heel cuts and hole drilling for the explosives. And then again, the design check included the review of the structure at each stage, checking the stability of the different sections and ensuring that the thing remained stable until we blasted out the final section and induced that collapse. And the idea is, once all the planning is in place, the demolition can commence. And what the philosophy is that with any pull down or blow down is to get the structure on the ground so that then it can be processed using heavy plant working from ground level. And we want to reduce the working at height due to it being a significantly dangerous activity in the construction industry. So this type of demolition is high risk, yes, but it's for a very short period of time. and controls such as a site-wide exclusion zone, they can be implemented. So that keeps the overall risk much lower than alternative methods, because it's high risk, but for a very short limited time. And here's how this one went. It's just a short video. So some the initial blast to remove that final section of the structure.